Okay, so now the last topic, that is Kohlrausch law. Okay, see. Okay, so what essentially tells of what is Kohlrausch law? Now, Kohlrausch law is essentially tells that if you are taking an electrolytic component, electrolytic compound, and you are trying to make the solution of that, so then essentially if the value of that particular electrolytic component, okay, so electrolytic component in terms of infinite dilution, okay, so that is essentially equal to the component of that cation and the component of the anion that's particularly made that particular electrolyte, that essentially not only ionic conductivity, the molar ionic conductivity of that particular cation and anion, if we sum it up, the molar ionic conductivity of that particular anion and cation, that is essentially equal to the infinite dilution of that particular electrolyte. Okay, so just go with me and I will discuss a little bit more. Okay, so here the mathematical term says that lambda m0 is essentially equal to nu plus lambda 0 plus nu minus lambda not minus. Okay, so lambda plus nu plus and nu minus, that is essentially equal to the number of cations and anions made from a particular electrolytic solution. Okay, okay, so then the small lambda 0 plus, that is essentially equal to, okay, so I'll mention just a second. Okay, so lambda plus is essentially equal to number of cations, correct? Lambda minus is equal to number of anion, and lambda 0 plus, that is essentially equal to the cationic molar ionic conductance, and lambda 0 minus is essentially means anionic conductance. Okay, okay, and what is the lambda 0 m? The lambda 0 m is essentially molar conductance of that particular electrolyte at infinite dilution. Okay, so molar conductance at infinite dilution. Okay, so that is essentially the Kohlrausch law. Okay, so please go with me. That is, I will explain a numerical problem in related with Kohlrausch law. So then you will get the actual essence of the Kohlrausch law. What, what is the question? The question says that at infinite dilution, molar conductance, molar conductance. Okay, so just a second. At infinite dilution, okay, what happens? molar conductance of HCl, NaCl, sodium acetate are 426.2, 126.5, 91.0 ohm inverse, centimeter square, mole inverse respectively. Now the question is calculate. Now the question is calculate the molar conductance obviously at infinite dilution, at infinite dilution of acetic acid, CH3COOH. Okay, so now follow, I will proceed with this problem. Okay, okay, so let me write this. Okay, so see, the value of molar conductance at infinite dilution of HCl, NaCl and sodium acetate is given, and you have to calculate the value of molar conductance at infinite dilution of acetic acid. Okay, so then the lambda, capital lambda 0 of HCl that is given is essentially equal to what is the value now, 426.2. Okay, so if you consider the dissociation of HCl, so that will dissociate in terms of H plus and Cl minus, correct? So number of H plus is 1 and number of Cl minus is 1. So if you consider the previous Kohlrausch equation or Kohlrausch laws equation, then we can write that is equal to lambda 0 of H plus plus lambda 0 of Cl minus. So that we'll consider as equation 1. Okay, so then try to write this initial in the same manner. Okay, so lambda 0 of initial that is equal to 126.5. I will deliberately ignoring the uh, uh, unit here, so I'll put in the final expression. Okay, so if you want, you can write here also the unit. Okay. Okay, so initial that is essentially initial dissociates like Na plus and Cl minus, so that is essentially equal to lambda 0 of Na plus plus lambda 0 of Cl minus, correct? And I will consider that as the equation 2. Okay, so now consider the last one, that is lambda 0 of sodium acetate CH3COONA, that is essentially equal to 91.0. So you will dissociate sodium acetate, then it's dissociate Na plus and CH3COO minus. So that is essentially lambda 0 of Na plus plus lambda 0 of CH3 C double O minus acetate ion. So that is essentially equal to 3. Okay, so now what will want to we will want to calculate that that is the molar conductance of acetic acid at infinite dilution, correct? So we will try to calculate the lambda 0 of acetic acid. Okay, we will try want to know what is the value of that. So that is essentially we know that is equal to CH3COO minus the acetate ion plus lambda 0 of H plus. Okay, so we will try to get these expression. We will try to get okay, so let me use this another color. So okay, we will try to get this expression from these three expressions. Okay, so this is our motto to do that, how we'll get this expression from these two expression. Okay, so we'll get a lambda 0 of H plus plus lambda 0 of CH3COO minus. So lambda 0 H plus is essentially here. Okay, so lambda 0 of H plus is essentially here. You see, lambda 0 of H plus is essentially here, and lambda 0 of CH3 C double O minus is essentially in the third equation, correct? Okay, so just a second. Here it's given. Okay, so try to manage these three equations to get only these three, and rest of the terms we don't need. So that's why we'll try to arrange these three equation is as a manner that the other terms will get cancelled out. Okay, so we'll do that. What can I do? We'll do that one equation 1 minus equation 2 plus equation 3. Okay, now what we'll get? Now we'll get that try to 426.2 minus 126.5 plus 91.0, correct, from the left hand side, and from the right hand side we'll get lambda 0 of H plus lambda 0 of Cl minus lambda 0 of Na minus lambda 0 of Cl from equation 2 plus lambda 0 of Na from equation 3 and lambda 0 of CH3 C double O minus. Okay, so plus lambda 0 of Na and minus lambda 0 of Na will cancel out, and plus lambda 0 of Cl and minus lambda 0 of Cl will cancel out. So now we'll got that lambda 0 of H plus lambda 0 of CH3 C double O minus, and that is essentially equal to lambda 0 of acetic acid. Okay, so you will, if you will calculate that 126 426.2 minus 126.5 plus 91.0, then you will got what is the value, and then you will got 390.7, and then put the equation, that is a unit, the ohm inverse, centimeter square and mole inverse. Okay, so that is the essentially one type of a numerical problem in terms of Kohlrausch equation. So please try to do then another month. There is a basically same with this one. Okay, so but try yourself to get convinced that you will understand the concept, but the numerical concept totally. To understand it, please try it, that at infinite dilution, molar conductance of barium hydroxide, barium chloride and ammonium chloride are, so put the value 523.28, 280.0, after that 129.8 ohm inverse, centimeter square, mole inverse. Then calculate the molar conductance at infinite dilution of ammonium hydroxide. Okay, so I'll give you the answer. Okay, so then try to solve it. If not, then let me know. The answer you will got, that is essentially equal to 251.44 ohm inverse, centimeter square, mole inverse. So try to use this equation, that is lambda 0 of m is essentially equal to nu plus lambda 0 plus nu minus lambda 0 minus. So don't forget to write this nu plus and nu minus, that is essentially equal to the number of cation and number of anion. So please do it yourself, and okay, so today up to this, and this is the last portion of electrochemistry. So we'll done the electrochemistry chapter. Okay, thank you.